Stargazers and space experts are stunned by the looming vanishing of the North Star, Polaris. This occasion is expected to be the next enormous thing in the universe of astronomy. Yes, you heard that right. Polaris is going to be scoured off our stargazing map for good, and this approaching heavenly upheaval conveys significant ramifications for our ground-based telescopes, which use it as a reference point for their adjustment and precision. Furthermore, Brian Cox warns that Polaris blast is inevitable and will change the night sky forever. We should dig further into the tale of the North Star and why its end matters so much. For centuries, Polaris has been a divine guide for both astronomers and pilots. Yet all of this might change in merely many years, if not years. A recent examination work presented to the esteemed Royal Galactic Society in September 2023 has essentially fixed the destiny of this guiding light. Polaris is on the edge of a calamitous event, an explosion that could bring about its vanishing from the night sky for eternity, changing our infinite compass. Yet, before we dive into the expected results of this discovery, we should investigate the star being referred to. Otherwise known as the North Star or Pole Star, Polaris holds a unique position in our night sky due to its closeness to the heavenly North Pole. It sits straight above Earth's North Pole, giving the illusion of being practically fixed in the northern sky. Situated in the Ursa Minor group of stars, which is also known as the Little Dipper or the Little Bear, Polaris shines as a fairly radiant yellow-white supergiant star. It surpasses the Sun in iridescence, transmitting impressively brighter across the vast material. In addition, as far as sheer size, it overshadows our Sun, boasting a radius estimated to be multiple times larger. In spite of its apparent peculiarity, Polaris is part of a complicated triple-star framework. Two of these, Polaris AA and Polaris AB, appear as a single star to the unaided eye. A third companion called Polaris B orbits this binary pair. The complicated gravitational interactions among these stars impact their orbits and glow. These complex elements can cause irregular variations in the star's brightness and pulsation patterns. However, the exact mechanisms behind these interactions remain an invaluable puzzle. On top of all of this, the varying distance of Polaris from our planet adds an interesting temporal twist to our understanding. Since it is 323 light-years from us, the light we see from Polaris today left on its interstellar journey more than 3 centuries ago. If we were to see Polaris explode right now, it would have actually done so centuries ago. The Earth a long time ago was very different. In the mid-18th century, humanity was navigating through a period marked by significant historical events and social movements. It was a period that marked the end of the Renaissance period, the beginning of the Enlightenment, and the dawn of the Industrial Revolution. In several areas of the planet, scientific advancements were gaining speed with figures like Isaac Newton forever changing the scientific landscape. In terms of daily life, society was still largely agrarian, with farming being the primary occupation for most people. Urbanization was slowly gaining momentum, leading to the growth of cities and the expansion of trade and commerce. Culturally, lavish music and art were gaining prominence. So, if Polaris detonates tomorrow, it would have actually done that when Earth was in the midst of a time of exploration and change, setting the stage for the developments that would shape the centuries to come, just like how this event would change things for our future. Throughout the centuries, the North Star has wound around its significance through the tapestry of civilizations across the ages. This heavenly reference point served as a guiding light for ancient seafarers and travelers, illuminating their paths across vast seas and unknown landscapes. Polaris is a reliable beacon, guiding pioneers in the Northern Hemisphere, enabling them to chart courses with confidence. Polaris has embodied a cultural and navigational cornerstone for millennia, and shaped the story of ancient explorers, storytellers, and scientists alike. So, how do we know that the star is approaching its end? Named a variable star, Polaris has distinct properties and astronomical measurements. Its predicted brightness changes have been instrumental in unraveling mysteries about variable stars and aligning cosmic instruments. These rhythmic throbs have generally followed a reliable pattern, helping astronomers in predicting its behavior. However, in a recent research paper, scientists revealed a deviation from this normal pulsation cycle that has begun to worry the astronomical community. Polaris has taken on an unpredictable rhythm of dimming and brightening, This anomaly has prompted intensive study among astronomers eager to understand this volatile anomaly. This departure from its norm has ignited concerns among scientists, indicating that Polaris may indeed be approaching the sunset of its existence. Polaris' pulsation period has recently begun expanding. The star was previously stable in its cyclic brightness shape. However, astronomers have noticed a gradual lengthening of the pulsation duration, with an annual increase of 4.5 seconds. While seemingly small, this change holds significant implications, suggesting a departure from its established behavior. There have been several theories on the matter. Some attribute this shift to gravitational interactions within the Polaris star system. These interactions could be altering the star's atmospheric conditions, directly influencing its pulsation patterns, or more specifically, how we perceive them. However, dissenting voices among mainstream scientists suggest an even more alarming possibility. The star is dying. Whether it's a result of gravitational exchange or a harbinger of an imminent celestial explosion, the abnormalities in Polaris behavior have ushered in a new era of astronomy. One way or another, the truth is set to change everything we thought we knew about triple star systems like Polaris. Talking about how discovery changes our perspective, it was in 2006 that we got a close-up check of Polaris courtesy of the Hubble Space Telescope. Astronomers also revealed the elusive companion star nestled so intimately close to Polaris that it had been difficult to notice it beforehand. This was the very first photo of our heavenly neighbor, capturing its bright light. Today, we know that the companion Polaris B orbits the central pair at a distance of approximately 2 billion miles. Although astronomers had inferred its existence from light studies of the triple star system nearly a century ago, its faintness compared to Polaris deterred direct observation until the Hubble Space Telescope made it possible. This all began with the launch of the Hubble Space Telescope, HST, in 1990. Its deployment opened a window to the universe, providing unmatched clarity and redefining our understanding of astronomy. The HST captured celestial wonders that reshaped our fundamental understanding of space. Among its notable achievements stands the iconic image known as the Pillars of Creation in the Eagle Nebula, which houses epic pillars of gas and dust where stars are born. Another milestone moment came with the discovery of the Hubble Deep Field, an apparently empty patch of space that upon closer inspection was teeming with thousands of galaxies. This single image expanded our view of the universe's sheer vastness and complexity forever. The HST also studied exoplanet atmospheres and revealed tantalizing clues about their composition, such as the presence of elements like water and organic molecules in these distant realms, indicating the potential for habitability beyond our solar system. Building upon the legacy of Hubble, its successor, the James Webb Space Telescope, JWST, was launched to push the boundaries of technological advancement even further. Drawing lessons from Hubble's exploits, the JWST is poised to delve deeper into the mysteries of the universe. Continuing the tradition of exploration and discovery initiated by its esteemed predecessor, the JWST stands ready to reveal previously unseen vistas of the cosmos with unprecedented clarity. One of the JWST's standout features is its unparalleled ability to capture celestial vistas with striking clarity, banishing the dark shadows that once obscured our cosmic perceptions. The telescope operates primarily within the infrared spectrum, piercing through galactic dust clouds and uncovering celestial treasures previously hidden from human sight. At its core lies a massive 6.5-meter primary mirror composed of 18 hexagonal segments, overshadowing Hubble's mirror in size and sophistication. This revolutionary telescope has heralded a new era of astronomical exploration, poised not just to unveil the distant reaches of the universe, but also to unravel the mysteries of our cosmic past. With its exceptional capabilities and unique vantage point in space, the James Webb Space Telescope stands as a beacon of human ingenuity, poised to unlock the secrets concealed within the celestial tapestry. Up until now, we know there are intriguing parallels between Polaris and Betelgeuse. Both of these giants are said to be nearing their ends. Betelgeuse is a prominent star in the Orion star cluster and has exhibited astonishing irregularities in its brightness, much like what we observe in Polaris. This similarity has prompted the astronomical community to monitor both stars closely, aiming to unravel the cosmic puzzle that ties them together. Now, as we embark on this grand journey into the vast unknown, the deductions drawn from Polaris hold particular significance. It stands as a testament to the ever-changing nature of our universe, where colossal anomalies transcend the bounds of time and space. Situated approximately 1.5 million kilometers away from Earth at the second Lagrange point, or L2, the JWST gracefully trails Earth's orbit around the Sun. From there, it gives us an unobstructed and vigilant eye into the cosmic web. Yet, the journey into the universe isn't just a journey across light years. It's a journey through time itself. The JWST uses state-of-the-art infrared instruments capable of peering billions of years into the past, capturing the ancient light emitted by celestial entities as the universe evolves. This light undergoes a transformation known as redshift, shifting from its original visible spectrum to the infrared.